It's just going to be hello. Sorry, I think I started talking before the recording. A quick recap of Unit 5 and 6. So trig functions and discrete functions. So here's a list of everything we did in each unit. And I'm just going to quickly go through them all and maybe show how to solve some stuff. Maybe just talk about it, just so the video is not 100 hours long. Okay, so let's start with just your basics. So we learned about the unit circle this year. We learned about how there's an initial arm right here on the positive x-axis, and this is called the terminal arm. We learned that the primary or principal angle, I think I called it principal, let's just change that name. I probably went back and forth. The principal angle is this angle that's formed between the initial and terminal arm. And we also learned about this guy, the related acute or reference angle. And that guy is formed when you attach the terminal arm to the x-axis and create a 90-degree triangle. So we're just able to figure out some values of sine and cos using this unit circle. So I just kind of connected it to the graphs of sine and cos. So we talked about how y is equal to sine theta and how x is equal to cos theta for the unit circle. We talked about how these points, like this is the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1, and how they correspond to the graph. So right here on the initial arm at an angle of 0 degrees, we can see that cos is our x value, so that's at 1. So that's why our cos graph starts at 1. And then we can see that sine would be at 0, so that's where our sine graph starts. This whole section of the unit circle, the yellow, that's quadrant 1. You can see how all of all of the like x and y values are all going to be positive in that section. So like in between here, like these are all, any point in there is all a positive x or a y value, which is why in this yellow area of the graph, you can see that the graph for sine and cos, they're both in the positive section of, if you're looking at y, like they're both above the y-axis. You can see in this pink section over here, quadrant 2, it's the sine quadrant for the cash rule. You can see how like sine is still positive, but actually cos is negative. And that's because, remember, cos is our x values, so x is negative on that side of our unit circle. Then we get to quadrant 3, so down here the blue. You can see how actually sine and cos are both negative in this quadrant. So they're both below below 0 on the y-axis. And then in this quadrant over here, just cos is positive. So see how our blue graph, which is cos, that is positive, but our sine curve is still negative. So we can use this unit circle to, just connect graphs and values for sine and cos. It can help us solve angles. It can find us multiple angles for certain ratios. It's very handy. So it's definitely important to be able to connect the unit circle to the graph. Okay, let's just talk quickly about special triangles. So we learned 2 special triangles, which you should memorize. The 30, 60, 90 and the 45, 45, 90 triangles. And this is what they look like. So let's just show how you could find the what tan 150 is equal to. So we got that's 0, 90, 180. So we know that's going to be somewhere in quadrant 2. Let's just sketch it. So we know that 150 is our principal angle. So that's going to be this value right here, 150 degrees. So we're going to use a related angle. So this angle in here is going to be 180 minus 150, which is 30. So this is going to be our, I don't know if you can hear my children in the background, I apologize. Our 30, 60, 90 triangle. And if I label it the same way I labeled this one, I would have root 3, 1, and 2. So then if we also think about the cast rule, C-A-S-T, this is a sine quadrant, which means only sine is positive here. So I know the answer for tan 150 is going to be negative. And I know tan is equal to opposite over adjacent, or y over r. So that would be equal to negative 1 over root 3. And I should probably rationalize the denominator. So I'll just multiply top and bottom by root 3, which equals negative root 3 over 3. So that's what tan 150 equals. And let's do sine of 225. So 225 is going to be down in quadrant 3 here. So this angle right here is 225 degrees. So our related acute angle, or our reference angle in here, is going to be 225 minus 180. That will get me this guy. So that's going to be 45. So I got my 45, 45, 90 triangle. So I'll just label that as 1, 1, and root 2. So sine of 225 is going to be negative, because C-A-S-T, I'm in the tan quadrant here. So sine will be negative. And it's opposite over hypotenuse, so 1 over root 2. And if I just rationalize the denominator, it equals negative root 2 over 2. So that's special triangles. I can also work backwards. So if I know that cos of some angle is negative 1/2 and I want to find theta, I can do that. And I usually would give you a domain for that, because there's going to be an infinite number of answers for this. So if we're just talking between 0 and 360, well, maybe I want to think like, so according to the cast rule, cos is only negative in these two quadrants. So those are, I'm going to have two different answers. So let's just talk about this quadrant right now. So in order for cos, which is adjacent over hypotenuse, to be negative 1 over 2, I know it's going to be negative 1, 2, root 3, because I recognize those numbers. So I know this is going to be a 30, 60, 90 triangle. And I just know that because I'm quite familiar with my special triangles. So now I'm looking for the principal angle here. So theta is going to equal 180 minus 60, or just 120. And then I got another answer that's going to be in quadrant 3. So I'm going to use that adjacent over hypotenuse. That's going to be root 3. So I know that's 30, 60, 90 triangle. So another value for theta is going to be 180 plus 60. So 240. So I've got two different answers to that. Okay, we can also get ones where it's not a special triangle. This time we've just got a point. We're creating that initial terminal arm thing. So if I just plot the point like 5 on the x-axis, negative 12 on the y-axis, so say I'm like down there somewhere, I always connect that back up to the x-axis to make my triangle. So I know that this would be 5 and this would be negative 12. So I want to find my radius. So I'll use Pythagorean theorem. So 12 squared plus 5 squared. Solve that, and I find that the hypotenuse is 13. Okay, so I want to find my primary and reciprocal trig ratios. So I would just write, that's theta, so I would just write like sine theta equals y over r, or opposite over hypotenuse, so negative 12 over 13. Cos theta equals 5 over 13, and tan theta equals negative 12 over 5. Now I am in the cos quadrant here, so cos should be the only one that's positive. And then my reciprocal, I got cosecant theta equals negative 13 over 12. Secant theta equals 13 over 5. And cotangent theta equals negative 5 over 12. And then for part B, I want to find my primary or principal angle. So first I can find my related angle by using one of my trig ratios. So let's just use, I might use tan, because just in case I messed up my hypotenuse, I know tan's not messed up. So to find the reference angle, I'm going to do inverse tan of 12 over 5. So inverse tan of 12 over 5 is...
Hey girls, time to go to the bath.
67 degrees. So that's this angle in here. So to get my principal angle, I'm going to do 360 minus 67, which is 293 degrees. That's my primary or principal angle. Trig identities. So these are all your trig identities. All of these, they're going to be on your exam and on your tests. And I'm not doing an example in this video, but check out the other video if you want to learn how to solve it. I'll just say tips for trig identities. I like to start with the more complicated side. Actually, I'm not going to write all these. Sorry, it's going to take forever. Start with the more complicated side. So I'll just write, choose your side wisely. Or if that doesn't work, sometimes I choose the side that has tan in it and I change it to sine over cos. Try making a common denominator. That's like often a strategy that works. Or possibly factoring, that could work. Replace some stuff. So like use some of these guys to replace things. Okay, moving on. Graphing. I didn't, so that must mean, yeah, I skipped sine and cosine law. No, let's not do it. Okay, graphing. So to graph trig functions, let's start with just stating the key features. So our amplitude for this one is just 3. So this guy, the a value, you don't need to put the negative. In fact, don't put the negative. The period of this trig function is 360 degrees. There's no k value. And our equation of axis is at y equals 1. So we know 1 is going to be like the middle of our graph. We also have a reflection, the negative, so our graph is actually going to go down first. And all of our points are shifted up 1, and our y values are all multiplied by 3. So I'm just going to wing it. I'm going to say it starts at 1. Normally it's at 90 and 1, but now it's going to be at 90 and -2, I guess. 1, 2, 3. Yeah, because it's going to be 3 down because we know the amplitude is 3. And then it's going to go back up, so 180 and 1. And then at 270, it's going to be 3 higher than my equation of axis, so it's going to be at 4. And then back to 360. It's going to look like this. If you want to do your points, you can just list them like 0, 0, 90, and 1, etc. Like list all of the points. And then you're going to multiply all your y values by -3 and then add 1. So this one becomes 0, 1. This one would become 1 times -3 is -3 plus 1 is -2. So that's what you would do. Okay, next one. Let's go through all the key features. So you got an amplitude of 1. You got a period of 360 divided by k. So 360 divided by 2 is 180. Your equation of axis hasn't changed, so it's still going to be at 0. And you're going to get shifted to the right 45 degrees. And it's cos. So my points are 0, 1, 90 and 0, 180 and -1, etc. So what I'm going to do for this one is I'm going to take all my x values and I'm going to divide them by 2 or multiply them by 1 over k, which however you want to think about it. And I'm going to add 45 because I know they're getting shifted 45 to the right. So 0 divided by 2 is still 0, and then add 45. So I'll be at 45 and 1. This one, 90 divided by 2 is 45, plus 45 is still 90. Then 180 divided by 2 is 90, and 90 plus 45 is 135. So let's just see what that looks like. So I got a point here, I got 90 and 0. 135 and -1. And then if I just keep that pattern going, I'm going to go here and then up here. And actually, I think I'm going to start at 0, 0. So that's what my cosine, that's what this graph's going to look like. And it's going to just keep following that pattern. All right. Oh, that's it. I didn't even write any discrete questions. Awesome. Okay, well, let me just quickly walk you through discrete. Oh, and I didn't walk you through any Ferris wheel questions. Sorry about that. They're not on the exam, though. Okay, so some sequence questions. There could be arithmetic or geometric sequences. So remember, arithmetic are the ones that would go up, like add by a certain amount or subtract. So like 1, 3, 5, 7. We would know that A is equal to 1 and D is equal to 2 is going up by 2 every time. So if we had to write the general formula for this, we would say A plus n minus 1 times 2, and then we would just simplify that. So 1 plus 2n minus 2. So 2n minus 1 is our general formula. Or if you had a geometric, so maybe it's going to be like 1, 2, 4, 8. So our A value is 1, but this time we have a common ratio, which you can get by doing T2 divided by T1. So our common ratio is 2. It's getting multiplied by 2 every time. So our general formula would just be A, which is 1, times 2 to the power of n minus 1. That got really messy. So you don't really have to write the 1. You could just say 2 to the n minus 1. That's sequences. Obviously, there's more to it than that, but just a quick video. You could be asked to find a certain term number. Sorry, just to say a couple more things. So if you wanted to find term 2, you would just sub 2 in for n. And you would see that term 2 is 3, which it is. Same, it works for both of them. Series. So series are when you add up an arithmetic sequence or a geometric sequence. And we learned the formulas for those. So basically you're just subbing in numbers into a formula, so I'm not going to review that. And finally, one of my children have arrived. Hello. Try not to cough on me. The binomial, it's okay. The binomial theorem is that Pascal's triangle thing that we learned. It looks like this. And you can just use it to expand binomials. So say you had like x plus 2 to the power of 3. Then you know you are on the third row. So this is row 0, row 1, row 2, row 3. So you're going to use this guy. Those are going to be your coefficients. 1, I need my arm to write with. 1, 3, 3, 1. And then you're going to start with x cubed, x squared, x to the 0. I'm totally running out of space. All these arrows everywhere. I'm sorry, I'm also running out of time. And then 2 to the power of 3 will be down here. 2 to the power of 2. No one can even see what I'm writing. It's really ridiculously smushed in.
Why didn't you just start right there?
I know. So if I simplify all this, we can even read it. I've got x cubed plus, I think here I've got a 3 and a 2. So I'll make that a 6. I don't know, that's what it looks like to me. 6x squared plus, what does that look like? 2 to the power of 2, so 4 times 3 is 12. 12x plus 8, maybe. I don't know. I think so. You think? Anyways, that's kind of how the binomial theorem works, but it's not on the exam, so. The end.